Hello, today we'll be going over IR and MS, or infrared spectroscopy and mass spectroscopy. We'll begin with the basic concepts, and then we will analyze a spectrum from both different methods. To begin, we'll go over infrared spectroscopy. We'll begin by looking at a spectrum, and then I'll go over some of the basic concepts. On the bottom, you have the frequency, and on the x-axis, you have the transmittance. In IR, you have 5 zones that are of importance. Zone 1 starts at 3700 and goes to 3200. Zone 2 starts at 3200. It goes to 2700 or thereabout. Zone 3 starts at 2300. It goes to approximately 2000. Zone 4 starts at 1850. It goes to about 1650. And Zone 5 is 1680 to approximately 1450. And everywhere beyond that is known as the fingerprint region, which has information which is hard for us to process it. As you can see here, each different region or zone has different chemicals that'll be displayed within it, such as you can see aromatics are often found in zone number 1 or 2. You'll also see that alcohols are found in zone number 1. We will begin by looking at the IR for a phenol, which is C6H2O. As we begin, we will analyze the 5 zones. We will look at each peak and try and give a definitive functional group to each peak. As you see, the fingerprint region doesn't really provide much information to us. Then we look down here into zones 1 and zones 2. We can see that there's some definitive peaks here, information we can draw, but beyond that, there's not much more in any of the other zones. As you can see here, there's a large round tip, and this is indicative of an alcohol. And then there are some smaller peaks here, which are usually associated with aromatic rings. And if we go up to our reference guide, it can be seen that that will align with the expected spectrum. Next, we'll do a MS and a mass spectroscopy. Across the bottom on the y-axis, or the x-axis, you have hertz, and on the y-axis, you have relative intensity. Beginning with the mass spectrum, you try and find the molecular ion, which is the largest peak, or the most forward peak, which for the phenol spectrum happens to be up here. Then you go down and try and find a base peak, which is the next most stable peak, which would be right about here. 67, 68. And since we know that this is a 96, the loss of an alcohol would explain this right here. Although the proper way to do this would be to then try and calculate the number of atoms in the molecule by taking the base peak or the molecular ion and adding the weights together, and then minusing off the known groups such as that oxygen or the alcohol, which would weigh about 17. And then you would be able to minus the number of carbons, and based on the degree of unsaturation, which can be found using the formula 1 plus C plus the number of nitrogen over 2 minus the number of hydrogens over plus the halides over 2. And for a phenol, the degree of unsaturation, which would be 4, would make this spectrum appear fairly correct. Thank you for your time. This is a basic understanding of IR and MS.